బాగానే ఉన్నాం. Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy Infinity Learn NEET YouTube channel. This is Dr. Suresh, Faculty of Chemistry. Today we are going to discuss the reaction intermediates in NEET examination preparation, right? So let's discuss the reaction intermediates. So it is very important concept for your organic chemistry preparation. So when you see the organic chemistry for the NEET examination, in 2026 NEET examination, it was slapped like anything. Because of the re-NEET and the paper leak, and their attention is turned in the different way. But after completion of examination, if you analyze the paper, it was, as far as organic part is concerned, it is not as easy as what people thought. So we want to just discuss this particular concept of reaction mechanisms and reaction intermediates for the betterment, better understanding, better applications for the NEET examination. Hello, hi Surya Pratap. So let's discuss about the reaction intermediates. In the reaction intermediates, the basic fundamental thing, a chemistry reaction is the conversion of reactant to the product. While converting from the reactant into the product, the old bonds are broken and the new bonds are formed. So when the old bonds are broken, you are going to get an intermediate depend upon the type of the bond breaking. So let's talk about the organic reactions, the process where reactant by the effect of the reagent you are going to get intermediate, and this intermediate is going to give you the product. And in the reactant, the old bonds are being broken. In the product, new bonds are being established. And the schematic representation, the study of how old bonds are broken and how new bonds are formed. And that is called reaction mechanism. So we will see first how the old bonds are broken. The old bonds can be broken between two atoms by means of two methods. One is a homolytic fission and another one is heterolytic fission. Those students who are online, please like the session and share with your friends and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel so that rise with our Infinity Learn Sri Chaitanya Academy YouTube channel. So you may think that on the YouTube channel, when you attend the lectures, can we clear the NEET examination? Yes, you can clear the examination and you can be topper as well. So in that we see Nirmaan 1.0 series we are running here. In this series we will be discussing all the concepts of various parts of the NCERT textbook at the level of NEET examination. You need not have to pay anything. Just you attend the class on the regular basis and take the noteworthy points, and we will be providing you some questions and tips and tricks, and you can work with your books, and that's it, and you can do the best for your NEET examination. That I can say that. So this session is very much important for the NEET dropper and grade 11 students and grade 12 students. Stay tuned and we will discuss about the types of bond fission, homolytic fission and heterolytic fission. Surya Pratap, hello. And you can see various types of homolytic fission. When the bond is exactly broken to half, you are going to get free radicals. You are going to get free radicals. So my question is homolysis, homolytic fission, in which condition this takes place in the organic chemistry? This takes place in the organic chemistry in the presence of peroxide. जब peroxide आएगा ना, तब आपको homolytic fission होना चाहिए. और अगर ये रिएक्शन लाइट का प्रेजेंस में जाएंगे तो, सो प्रेजेंस ऑफ लाइट and very high temperatures and also you can also say vapor phase reactions. Vapor phase reactions, in these four conditions you are going to get free radicals. Say an example here, chlorine in the presence of sunlight, UV sunlight or diffuser light or HNU, whatever, you are going to get Cl free radicals. You might have seen this free radical systems in alkanes, right? Yeah, I want to talk to you about the something important. Yesterday during the class, the student was being extremely rude and was disrespecting me and my parents. If that is the case, you can report it and we can just delete that kind of charts, or we can retract that such type of messages. Okay, those students who are online, please maintain the chart diagram, use this chart box, and this chart box is very useful between you and me for making a good conversation. So any conversation is open which is academically driven. If out of the academics, you please never use that. Fine, Surya Pratap, and you can just report us and we are going to just retract the such type of messages. So students, let us move ahead with the homolytic fission. Any doubt as per homolytic fission? Geeta Madhuri is there in the class, and Surya Pratap, let us talk about heterolytic fission. And this is a heterolytic fission. This heterolytic fission, if A and B are the two atoms, and this is a bond pair of electron, let us say electronegativity of B is greater than A, ताकि इसका जो इलेक्ट्रॉन पेयर होगा ना B का तरफ जाने का बाद B माइनस होगा, A प्लस होगा, ताकि इसका anion बन जाएगा. It is going to be anion and this is going to be cation, right? Anion and cation. Are you getting or not? If that is the case, you are going to get carbocation. I have 14445 rank, OBC 5118, APM eligible, any aims 5000 is chance, okay. How to read chemistry, that's what we are making a journey. Join in our journey, so I'll make you to how to read chemistry. Ready? So reading chemistry is really like a journey, right? Arun Devi, right? Okay. So dear children, let us focus here on the carbon intermediates. When the reactant, the old bonds are broken and new bonds are going to be formed. Before going for this new bond, old bonds are broken, so that you are going to get intermediate. These intermediates are various types. Let it be carbocation, so carbon radical, so you have carbon radical, carbanion and carbocation. Apart from this, you have from which chapter I need to start? Whenever you start chemistry, you start from some basic concepts of chemistry, atomic structure, periodic table, chemical bonding. Then only you can jump into any chapter. You want to study directly thermodynamics, you can't do it. You want to study directly equilibrium, you can't do it. You want to do some organic chemistry, directly you can't do it. Rather, you have to work on the fundamental aspects, okay, of atomic structure, writing electronic configuration and quantum numbers at least, and periodic classification, chemical bonding. Then only you can start a journey with chemistry. Fine? Okay. Now, any kind of doubts you can ask us, so that we can have a discussion. So, you have a carbon intermediates, and the carbon intermediates which includes carbon free radicals, carbanions and carbocations. Apart from you have carbenes, nitrines and benzyne, and we will be studying in the future classes about this. Now let's talk about your studying Bharadwaj Goshala. Okay, very good. So let's move ahead with the carbocation. What is the carbocation? Carbon with, let us take CH3 plus as an example, right? So carbon undergoes sp2 hybridization. So when it undergo sp2 hybridization, you are going to have carbon, hydrogen and hydrogen and hydrogen. You have unhybrid pure p orbital lies perpendicular to the plane of the triangle. So this is a triangular in shape, and you have 6 electrons in its outer shell. Okay, it is octet configuration and it is a positive charge, and you have vacant p orbital perpendicular to this plane of triangle, vacant p orbital. So this has 6 electrons, and this is the basic structure of a carbocation. It is a trigonal planar structure, trigonal planar structure. And the stability of carbocation depends on the various electronic effects. So stability of carbocation is directly proportional to positive mesomeric effect and positive inductive effect. Among all effects, have you seen it? What you want me to see? What you want me to see? Yes, have you shown to me? Come on. So this is about the carbocation stability. So in this carbocation stability, I just want to say the best order of stability among all carbocations, I just want to say cyclopropyl methyl carbocation is the most stablest carbocation because of the dancing resonance. And after that you have trophylium carbocation. You have trophylium carbocation is more stable, and allyl carbocation is more stable. Then it is going to be tertiary carbocation is more stable. Then secondary carbocation is more stable. Then primary carbocation is more stable. Then methyl carbocation is more stable. Then vinyl carbocation, of course vinyl carbocation is less stable than phenyl carbocation. So dear children, here I just want to show you one more important thing here. I forgot to write, this is a benzyl carbocation. I forgot to write this. So benzyl carbocation. So this is the order everybody has to follow. Cyclopropyl methyl carbocation, trophylium ion, and benzyl carbocation, allyl, this is a trophylium, and it is going to be benzyl, and it is going to be allyl, and it is a tertiary, secondary, primary, and a vinyl, and it is a phenyl. Okay, why I am writing by using my handwriting? That confidence you have to develop it. If you don't develop that kind of confidence, simply I can show some presentation, I can leave it. And you take a screenshot, and while I am drawing, what is the moral of the story? You are practicing along with me. So क्लास करने का वक्त में एक राउंड प्रैक्टिस भी होना चाहिए, समझ में रहे क्या बेटा? नाउ मूविंग अहेड, दो स्टूडेंट्स और ऑनलाइन, प्लीज कम ऑन, just let's talk about the carb anion. In this carbanion, I just want to take CH3 minus carbon, methyl carbanion. Who is going to give the hybridization of the carbon in the methyl carbanion? Waiting for you. Use the chat box now. Those who are online, give the answer for this question. And it is going to be sp3 hybridization. sp3 hybridization. Carbon, hydrogen and hydrogen and hydrogen and a lone pair of electron. This is a pyramidal. This is a pyramidal in geometry, and the carbon has 8 electrons, octet configuration. So of course it is more stable than. Hi Chauhan, how are you? It is going to be sp3. I appreciate your answer. That's good. And when it comes to the carbanion, the stability of carbanion, you are going to see is directly proportional to negative mesomeric effect and negative inductive effect. Fine? Negative mesomeric effect and negative inductive effect. And if you see, methyl carbanion is more stable than, primary carbanion is more stable than, secondary carbanion is more stable than, tertiary carbanion. Tertiary carbanion. Fine? Follow this order. Always you don't say the exact reverse order of the carbocation, because benzyl and allyl carbanions and carbocations are more stable. Very good. How about your preparation, Chauhan? Very good. And talking about the carbon free radical. If it is a carbon free radical, my dear students, CH3 dot. What is the hybridization of this, Chauhan? I know that you can give the answer. So I wanted to give you, it is sp2 hybridization. It is sp2 hybridization. In this sp2 hybridization, carbon, you are going to have hydrogen and hydrogen and hydrogen. It is going to be a triangular planar geometry. And this is going to have unhybridized pure p orbital. उसमें एक odd electron रहना चाहिए. Odd electrons. High carbon free radicals are highly short-lived neutral species, and carbon undergo sp2 hybridization, and this carbon has 7 electrons in its outer shell, and it is electron deficient in nature. So Chauhan, अगर कुछ डाउट है ना तो आप बता सकते हैं. इलेक्ट्रोनेगेटिव साइड एटम के इलेक्ट्रोनेगेटिव ग्रेटर देन 2.5, देन इसका हाइब्रिडेशन sp3. Exactly you have given. Exactly you have given the correct. And कार्बन फ्री रेडिकल का स्टेबिलिटी, कार्बोकैटायन का स्टेबिलिटी दोनों बराबर होगा बेटा. सो कार्बोकैटायन स्टेबिलिटी ऑर्डर एंड कार्बन फ्री रेडिकल स्टेबिलिटी ऑर्डर दोनों बराबर होगा, ताकि इसका साइक्लो प्रोपाइल मिथाइल कार्बन फ्री रेडिकल इज मोर स्टेबल देन ट्रोफाइलियम कार्बनियन कार्बन फ्री रेडिकल. ट्रोफाइलियम कार्बन फ्री रेडिकल is more than a benzyl free radical, is more than allyl free radical, is more than tertiary free radical, is more than secondary free radical, is more than primary free radical, is more than methyl free radical. Understood, Chauhan? Now, You have electron displacement effect. The reactivity or the stability or any acidic nature, basic nature, whatsoever the property is governed by electron displacement effects. They include inductive effect, electromeric effect, mesomeric effect and hyperconjugation. While deciding any factor, one property or one effect or more than one effect can be at a time can be used. So, what effect is going to be taken into the consideration, that's a noteworthy point. So, order of effects. Hydrogen bonding is the powerful as compared to the steric effect is powerful as compared to aromatic effect is powerful as compared to resonance effect is powerful as compared to hyperconjugation is powerful inductive effect. So, this is the criteria you have to follow when you decide any physical properties, chemical property, acidic nature, basic nature, reactivity, stability, whatsoever it may be. Sir, only you have written 4, but these many are there. And hydrogen bonding, steric effect, aromatic effect are not electronic effects. Only resonance effect and hyperconjugation inductive effect are the electronic effect, so that only this is shown. Sir, you are not showing this electromeric effect. Sir, electromeric effect is a temporary effect, but it is a strong effect. Okay, let's discuss some pointers. Let's discuss some pointers about the stability of the carbocations. Stability of the carbocations, okay. This works. In order to say, I just want to say the resonance. Resonance. As I said, the resonance effect is the super important effect. Students, while preparing for your organic chemistry, you have the first problem with the resonance only. So, resonance means actually there is something shown by arrow marks and different structures are shown, and which is the correct one. Only teacher understands, students usually don't understand. Don't worry, I'll make you to understand over here. Students, here rules to show delocalization. हर मॉलिक्यूल में रेजोनेंस नहीं देखता. Look at this. Rule 1, pi electrons are always transferred to an atom. In order to show resonance, the molecule should have the delocalization. It should have a conjugation. What is the meaning of conjugation? What is the meaning of conjugation? Separation by one sigma bond. I mean to say rule, conjugation rule. That is separation by one sigma bond. If pi bond and pi bond is separated by one sigma bond, I mean to say there is a resonance. Pi bond, sigma bond and a pi bond. And a carbon, double bond, carbon and the lone pair of electrons you can see. Lone pair, sigma bond and the pi bond. It is in conjugation. You can see carbon, double bond, carbon and CH2 plus. Positive charge sigma bond and a pi bond. Yes, it is in conjugation. And similarly, you are going to see C and CH2 negative. Negative charge sigma bond and a pi bond. So in order to show the rule, one is the pi electrons are always transferred from an atom to another atom. And electrons on an atom, negative charge and the lone pair are always transferred to make a pi bond. So during a resonance, electron always move from high electron density to low electron density across the conjugation. So that is the fundamental aspect you need to know about this resonance. And also electrons flow from the high density to low density. समझ में आ रहा है क्या? These are the noteworthy points I am giving you. You can directly use in the NEET examination preparation. Nirmaan 1.0. So today's program, from a few months after this, we are going to deliver the lectures for the level of NEET examination. Okay. Attend our lectures regularly and अगले सेशन में कौन सा टॉपिक आने वाला है आपको पता होने के लिए सब्सक्राइब दिस चैनल एंड प्लीज लाइक दिस Sri Chaitanya Academy NEET Infinity Learn YouTube channel and please share with your friends and subscribe so that the bell button दबाओ, आगे आने वाले का सेशन को नोटिफिकेशन भी मिल जाएगा. ओके चौहान, समझ में रहे क्या बेटा? अगर कुछ डाउट आने तो पूछना. Those students who are online, please like it. So rule number 1. So what is the meaning of a conjugation? I already said separation by sigma bond. You can see here. This is a carbon, pi bond and a pi bond, p orbital. So they are going to overlap like this. So they are going to form a double bond like this. Yeah. So I want to say, you want to say this is the CH2 double bond CH and CH double bond CH2. So what will happen? These are all having p orbital like this, p orbital like this, p orbital like this, p orbital like this. Huh? So there is a bond. There is a bond. Why not a bond here? They are going to form a bond here as well. So I want to say here CH double bond CH and CH2. You are going to see this is what is called delocalization. As a result of this, you are going to see a positive charge over here, a negative charge over here. So imaginary structures are drawn. These structures are called resonating structures. Students, in these resonating structures, that what exactly I have shown you. So conjugated systems. Let us talk about what is the type of conjugated systems. Remember, conjugation takes place only when p orbitals of the same symmetry are present. Same symmetry means they should be parallel. There is a pi orbital, the pi bond, sigma bond, pi bond. There is a conjugation here. It is a pi bond and separated by a sigma bond with a pi bond. So this is what is called as a sigma pi conjugation. Example, benzene and cyclohexane-1,3-diene. These are all. You want to know buffer solution? Mandiram, buffer solution, I want to take a separate session for this. You don't have to worry about this. Do you have a resonance here? Somebody tell me, Chauhan, you tell me, उसमें resonance है नहीं है? Resonance है नहीं है? No, 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 उसमें resonance नहीं होगा, उसमें resonance होगा, उसमें resonance होगा, उसमें resonance होगा. Okay? Understand? Understand? क्योंकि इसमें पाई बॉन्ड है, सिग्मा बॉन्ड है, पाई बॉन्ड है, सेपरेटेड. अंडरस्टैंड? क्लियर? नाउ और एक चीज है, you can see we have a pi alternative positive charge, a positive charge and a sigma bond A, pi bond A, so that it can have its resonating structures like this. Fine. Similarly, you have pi alternative negative charge, उसमें negative charge है बेटा. So that negative charge and a sigma bond and there is a pi bond. So that electron always move from high electron density to low electron density. Sir, electron density का order क्या बोलना है एक बार? You are going to say negative charge is more than, lone pair is more than, pi bond is more than, and odd electron is more than, and positive charge. Okay, this is the order. So electron always move from high electron density to low electron density. Everybody have to keep this thing in your mind so that resonance में arrow mark किस तरफ जाना है आपको पता होना चाहिए. Are you getting or not clear? That's good. Now we will be discussing in continuation of this in the next class about all these electronic effects, general organic chemistry for next 2-3 days in the same pointer I just want to discuss. So please, I am done for my side today, and those who are online, please like the session, share with your friends and subscribe to Sri Chaitanya Academy Infinity Land NEET YouTube channel. Okay, I am signing off. Thank you very much. Thank you.